stuff.
All right, hopefully we can listen and eat at the same time. And if you want more, you know, you won't bother me hopping up. I dropped this slide in because it gives us a good basic evaluation a lot of times when I'm looking at different sites. Google Earth is a magnificent thing. But this particular project actually delineated itself. So it was pretty easy to figure out where the problem was and what we had to take care of. But what helps me is in determining whether it's photo data, had a little conversation on the break. Data is everything. So the more information we have about what the problem is, the better we're going to be able to give you a cost-effective solution to fix it. If I don't have good data, I'm just going to slam it. And I'm going to make darn sure what I'm putting in is going to cover a myriad of problems. But if I know soil dynamics, if I know more information about what we're trying to achieve, it's going to be much easier. So am I working on 8 to 18% grades? Am I trying to regenerate some natural plant material that's already there? And how degraded is that material? How long has the spill been there? So any information that we can get, and again, I like picking on OSU because I spent a lot of time developing a good sodium and chloride soils testing protocol. And that gives us a lot of information about what the soil is doing in the health of that soil. If we simply get total soluble salts, chlorides, and EC, which is the bare minimum, I can figure out a course of action and a plan to go ahead and fix it, but it doesn't necessarily tell me all the things about how the product will react within the soil. So we're generally going to put in a little bit more product to cover ourselves, not knowing the actual soil chemistry. Let's get into the meat and taters. That sexy good looking guy sitting over there eating. Simple small area produced water spill. What's interesting is when the actual first site visit and the treatment is done, you can see these basic areas where there's Bermuda. Now Bermuda is very hardy, and Bermuda is going to grow in a lot of crappy situations, but it's good ground cover. But even in this situation, it wasn't very actively growing. Simply 13 days after application on one of the spot revisits and resampling, you can tell a significant difference. This area right in here is this area. That area up in here is right here. Now on the next slide I'm going to give you the data, but just remember, you would think if it's actively growing this aggressively that the soil or the salts and the chlorides would pretty much be gone. Not so much. At the 13-day mark, you still had 38,000 ppm chloride. I'm sorry, salts, 10,000 chlorides. Conductivity was still at 54,000. But that looked like it was growing like a house-afire. Very actively growing. Again, it's part of the process to where we're buffering that grow zone, the ability for those soils to regenerate themselves. Go ahead and actively start supporting new growth. Because the first part of our process is buffering those contaminants. Turning that soil around so that moisture can go ahead and penetrate down and in. Allow the plant to go ahead and start regrowing and reestablishing itself. Sending out rhizomes and stolons to send those runners out, to start continuing to cover and connect these areas. And get this little area back to an active pasture that surrounds a simple disposal site. Now, after 20 days, the levels continue to go ahead and drop and did very well. Now, again, this is 20 days, not 6 months, not 8 months, not a year. When I get to the next slide, George did both of these. Very simple process, but again, exceptionally high levels. quick response, a simple process, and we got dynamic results. Second location, again, same disposal site, other side, has similar spill, and I'm going to turn it over to George to kind of give his 2 cents worth in on how he prepped it, what was thrown in there to go ahead and reestablish it.
Okay.
So take it away.
All right. This one had much lower salt levels. We came in and tilled this to a depth of about 6 inches, and then put the remediation product down and diluted it. As I recall, we used about 75 gallons of water on this particular site. We did not have the initial testing. We went ahead and treated it early and then pulled the samples. Then, just to prove a point that we can get germination very quickly, I went ahead and put some millet and some sunflowers down. I also, since we had some impact in this area on the Bermuda, I went ahead and oversprayed this area, and after I had put down the millet and the sunflower, I also put some organic fertilizer that was high in nitrogen to stimulate the germination here, as well as to stimulate the growth of the Bermuda. And as you can see in here, it may be difficult. These lighter plants are the sunflowers coming up, the millet's coming up, and this was 13 days later. We actually had germination in 8 days or under on this. This is continuing to grow. The previous site, the cattle are actually grazing on the Bermuda that had the very high salt levels. This was about 16,000 parts, yeah, on this one. And you can see the sunflowers in here. From 1 week to the next, we were at about 5 inches on the leaf width, and it jumped about 1.5 inches in a week. This is continuing to grow in from all areas. We've got, when I was up there last week, we had 23-inch long runners of the Bermuda going into the sites. And these areas were also continuing to run out. So everything was starting to close in on it.
So usually everybody that does presentations and things like this only gives you the good stuff. But there are a couple interesting points on this actual plot. The other one continued to go down naturally, and it will continue to go down. But when we got our 15-day data, because this side was done a couple of days later than the other side, we actually saw 2 little rebound effects. Now most people would go ahead and get all excited and go, ooh, well, your product's not working. No. Again, because this one we actually treated blind, we had no data when we went into this one. We figured, well, we have a basic idea of what the other side is, so let's go into this one and treat it the same way. But the soil dynamics were completely different. So again, when I only get sodium chlorides and conductivity, we may not necessarily know all the actual reactions that could take place. Now that we have more information, this isn't unexpected. Weather patterns, the amount of moisture that goes through, was there a possibility this is a little down gradient site? Did we get a little backwash from some heavy rains that came in because we only had a smaller delineation of where we thought the problem was? Again, here's the good news. I'm fine that this went and jumped back up in 15 days, because the one that everybody really gets, again, the chlorides continue to go ahead and drop and will continue to remain stable. Generally, it's always the EC and the salt that we see potential rebounds. Now this, as I'll go ahead and show you on one of the later ones, let me jump ahead and then I'm going to jump back. We had the same basic effect on this site. This is a much larger site, about 1.75 acres. Again, relatively consistent numbers that we see quite a bit here in Oklahoma. But at the 60-day mark, we actually saw the numbers ramp back up. Now this was actually treated in late spring and went into the summer. This site was also what I'll call an aged site. It wasn't a fresh spill.
About 2 years old.
So it had plenty of time to work itself into the soils. It had been non-vegetated for a very long period of time. And again, we had limited data going in, but our treatment method, we still cultivated and we drenched. For a site about that, we're going to use roughly somewhere between 25,000 and 50,000 gallons of water per acre, depending on how many cubic yards. Now there's other companies that are out there that are recommending upwards of a couple of 100,000 to 1 million gallons per acre to try to go ahead and flush it. Well, water to me is a precious commodity. I need it as a delivery platform. I need it to go ahead and help get down into the soils and do the reactions that I need, but I don't need excess amounts of water. But when we went right at about the 30-day period, here in good old Oklahoma, it went completely dry and arid. Temperature skyrocketed, got very dry. So what we experienced here was a slight wicking effect. Some of the salt started to move back up from what we had filtered down below. Now, even though these numbers went back up and the REC went above the regulatory side, above the 4,000, the revegetation that we had on this was almost completed at 60 days and did not show any negative effects. It was a pasture off of a production pad that blew a line and basically ran down into a pasture, was right into a channel in a large grazing area. This area was reestablished right at about the 45-day point, remained stable, the cattle continue to go through, and today it's still fine. But we will get reactions and responses like this. Now, this site, which was same general area, another 2-year site, we did a little earlier in the year. And so when we came through the springtime with the nice rains that we normally get in the spring, it just kept driving our numbers down and down and down. And by the time we got to the 60-day mark, this site was perfect. Well, we didn't start the other site until we were somewhere in here. And we went to the dry period and the numbers went and played with us. So again, our job as a company, supporting our distributors and supporting you, our customers, is to tell you the time frames, establish the appropriate expectations. Make sure that you understand it isn't a perfect downward movement. Mother Nature has a lot to do with in situ remediation. Anything that we do on site, we need a certain help from Mother Nature, and moisture is one of those things. Moisture is always important for almost all remedial characteristics that you're going to do. So when we're doing different projects, again, we look at the amount of time frame that we have to do the project. These levels were relatively lower on both of these, and we went a little bit lower rate because there wasn't necessarily a speed or time frame that our customer was required to go ahead and do it. He was doing it. He actually owned the land that the spill went on. And so there wasn't a legal issue. There wasn't a mad landowner versus, the actual oil or gas company. So this one we were a little bit more relaxed and went with a lower rate, and we said we would need more time. Both these sites are completed and finished and done. So again, where we looked at those first couple, obviously the numbers on the first couple are significantly higher. The advantage that we had on these projects is that they were being done quickly. The longer you wait, the more money it costs to do it. These all we had to do was simple surface cultivations. Rototiller or a 3-point attachment on the back of a tractor, go ahead and get it tilled down 6 to 8 inches. It gets it nice and opened up. We lay the liquid treatment over the top of it. We can cultivate it again, hit it again. If you want to seed it, hit it with your seed, walk away, you're done and you're finished. Mother Nature and the product does the work from there. That's what's needed.
Let me step in for a second. One thing I've noticed in doing these projects over the last several years, the cattle activity. Initially, I don't see much activity on these particular sites. But after I've gone through and done the remediation, we really see an increased activity by the cattle. Both of these sites that we just recently did, cattle are grazing the Bermuda and the millet that was put down. So it's a noticeable change. And on the other older ones we did, the 1.5 acres and 1.75 acres, there's very little activity by the cattle. After we got through, it was incredible the amount of activity. The cattle were on the remediated site. They were adding donations, organic donations, shall we say, to the site, and it's a very noticeable difference by those animals. So they know it's safe, or they wouldn't be coming in.
So to tidy up the produced water side, our product's a liquid product, and within the biopolymer, it basically captures the sodium and chloride and holds it within that biopolymer. Helps free it from the soils so that it now will not have the negative impact to the soil structure, so moisture freely can go through, plants can revegetate. But it's also going to naturally allow the sodium and chloride to safely filter down through the profile. I'm going to pick on my regulators again. Sometimes people will go ahead and say, well, all you're going to do is move the problem to the groundwater. Well, we do consider that. If you have shallow groundwater, that is something that we need to look at, and we need to look at what the use of that groundwater is, because there is a potential that we will filter that out of the soils and into groundwater. But once it hits the actual groundwater, it's still going to be encapsulated in our polymer. Its specific weight and gravity is still going to be heavier than water. Once it hits the groundwater, it just keeps dropping. It keeps precipitating down as it comes out of soil. But you have to also remember something. Give me 3 feet of soil. The amount of years that it will take to move something from the top 8 inches to 3 feet down in soil, unless you have perfect sandy soil, is going to take a long time. A long time. It doesn't flush down and through. As you go through different striations of soil, you may have a bedrock layer, you may have different stuff of concentrations and porosity. So the water just doesn't naturally flush down through our soils. And if we're not getting natural rainfall that's naturally continually keeping our soils open and pushing, stuff doesn't move. Again, so what we're trying to do is to dilute it to a certain degree by moving it through a little larger striation, but to negate the negative effects of it. Do not allow it to re-encapsulate into the soil. Do not allow it to become a negative, because we do the same thing with heavy metals. Again, you can't digest heavy metals, but we know how to immobilize them, detoxify them, and protect them from the environment. Same thing that we're doing with sodium chloride. It's not a bad thing to have it, because we need a certain amount of salts in our soil to grow plants, just not as much as we donate when we have a produced water spill. So tidying it up, our product is simple to use, cost effective, and generally your results and expectations, depending on the budget and time that we have, we can get it done in fractional amounts of time in comparison to other competitive products. and we will get it done for the same cost competitiveness that most of our competitions have. And we're also going to use a lot less water resources to do it, which is more important to us than anything, is we don't want to go ahead and have to use other precious resources, but we do have to use a certain amount of moisture to actually get the project done. Now we're going to shift gears quickly into hydrocarbons. A lot of the same things hold true as far as when we actually have an oil spill. It impacts our soils and plants and nutrition and all of that. And as I mentioned before, our soils have millions and millions of bugs that are in it. But most of the time when we have an oil spill, a hydrocarbon spill, or even a produced water spill that has hydrocarbons, oils, gases, fuels mixed in with it, now you have something that is going to act as a preservative package to the natural microbes, because again, super concentrates of any contaminant will naturally put simple bacteria into dormancy. They go to sleep. There's way too much of it. Oh my God, I can't do anything. Go to sleep. Just like I do after a good dinner. So again, our product has multiple different technologies built into it to be a complete system. First of all, anybody that sells microbes or enzymes or even surfactants that doesn't actually admit that part of what you're trying to do is to get the natural general health of the soil to work in your favor is lying to you. Because there's more bugs per square foot of any soil than you're ever going to find and be able to buy and afford to put back into the ground. Yes, do I have bugs in the jug? Absolutely. Do I have the largest packages that are available in the commercial market? As far as I know, I do. But does that compare with what's naturally in the soil? I also want to fix the soil so that the soil's working for me as well. But what I'm putting in, what differs from what we do, is that they're natural bacteria that you're going to find in your soils around the world. There's certain strains of bacteria that naturally exist. So instead of trying to change and put something that's foreign in, I'm going to put healthier versions of what naturally exists, as well as put components to go ahead and start breaking down the hydrocarbons, like I said, turn apples into applesauce, and also have delivery mechanisms to be able to move those microbes around, because now I have an ability to have the moisture move around because I've changed that dynamic within the actual soil structure. We just completed this project not too long ago. Crude oil pipeline blew in the middle of wherever it was in Texas. Dumped a lot of barrels before they found it, wiped out a lot of the natural tree vegetation. Immediate response, they went in there, they dug the hole, they fixed the pipeline, got it isolated, did the mop up, and then it was our turn to come in. This is how it was when we started the project. Again, can't emphasize enough, and everybody knows it, first response, don't worry about me. Get it sopped up, get it stopped, get it contained, minimize it. When we came in, we had to go ahead and remove a few more trees because they obviously were toasted. Wasn't really a good ability for us to go ahead and leave them in place. It allowed us to go ahead and do a couple of different simple techniques. The first thing that we did is we went through, and this area was one of the rundown areas, the down gradient side. We just actually did an aggressive rototill. We dug the trees out and we just did an aggressive rototill, and we came back and we did a heavy drench with our treatment product and water. Just in front of this area was where the actual excavation was done. Went down, I think, 9 feet to where the pipeline was, so we excavated the material, threw it up there. They repaired the section of pipe that needed to be repaired. Unfortunately, we wanted to go ahead and treat it as they were layering it back in, but the repair crew beat us there. Got it fixed, put the material back in the hole. So I had a large area about the size of this room, 10 feet deep. Well, I couldn't drench it. So we basically brought a geoprobe in and punched holes on 10-foot centers, put screen piping into the ground, and did a gravity feed, to where we just hooked it to a tank with our diluted product, and it just went and soaked into the actual perforated lines and worked its way down through the soil profile. Now, the reason why I was fine doing it that way there is I knew all the material was just excavated, I knew it was slightly homogenized, and I knew it was open, and I knew our product with a little higher dilution would move through that loose material, and it did. We did some spot checks. We came back in a couple of days later. We did this on a 10-foot diamond pattern. So we had 3 holes that were in a little diamond, all 10 feet apart. And we came back in and did some spot checks with a geoprobe to make sure that in the center of those diamonds, the product was moving, and it did. So we knew we were getting good saturation. Normally, our pattern for a geoprobe injection or gravity feed is a little bit tighter. But again, it depends on the soil structure. This is what I'm most proud of. Again, we treated, reseeded. Most of the TPH, and that was the requirement that we were regulatorily following, the TPH ORR. Lowest was 14,650, 20,000. So it was an average of about 15,000 on the milligrams per kilogram, which is pretty standard for a blowout like this. 35 days, we basically got them all into single digits except for one site. And one of the sampling points was right at the beginning of the transition from where they excavated, had the heaviest impact of oil just out of the excavation hole. So it was slightly higher in its loading. But we were done in 35 days. Customer was ecstatic. We obviously planted it. That's what grew in 35 days. Or I'm sorry, when we came back in 42 days. But we got no further action in 45 days after this project. One of the fastest remediations I've ever done. So how did we do it? Well, one, fast. You get on oil, any hydrocarbon, when it happens, it's easily degradable. Breaks down fast, is consumed fast. All you have to do is make sure you have the proper loading of the remediation product in there. Second thing is, this is in a nice covered hollow. Stayed very, very moist. We had perfect remedial conditions. If this was sitting out in the middle of our good state of Oklahoma that gets a little dry and a little windy, it wouldn't have gone this fast. Reason being is the moisture content that was constantly in there, it helped move the product all through the profile. We had a nice moist environment, and if you know anything about molds or bacteria, it loves to be moist, warm, and wet.
Did you get any rains during that 42-day period?
Sure did.
Okay.
I mean, Texas this spring, when did they not have rain? We were getting it. I don't think this ever formally dried out for 90, 120 days. I don't think it was ever a perfectly dry site from when we started working it to where we finished and got the hell out of there. Now, that was very advantageous. And obviously I like it because the results were staggering and perfect. But it's also one of those examples that demonstrates if you get on fast, your consumption is going to be fast, your reaction and results are going to be more effective, and also the cost to do this is more effective. It doesn't mean that when you're in an arid state, because again, even if we didn't get the rain and the moisture in the way that's supposed to, your soil's still 4 to 6 inches down underneath. Usually maintain a certain amount of moisture and a certain amount of humidity in them, unless you go through a very extensive dry period or are in the desert or in very arid states. And in those situations, we've gone in, and if the remediation has to be done quickly, we've actually set up temporary irrigation systems to give it periodic moisture. That might be something that we have to do on the plan if there's a timetable that's done behind it. So it's knowing what the level of contamination that we need to get rid of. If it's simple benzenes. This project was one of our refinery partners. They now are doing things on an internal immediate response. The primary product that we use for hydrocarbon cleanup is called Soil RX. Soil RX has been reviewed by the EPA and is a Schedule 40 contingency plan certified product. What does that mean? Refineries can use it without asking anybody. Any federal cleanup, our product is certified to be used. You don't have to ask anybody to use it. Most states approve it because it's on that list. However, we still run through all regulators to get our product approved because it is organic, natural, and safe. But generally, the scrutiny that we've gone under, and the EPA has just re-scrutinized all of their products on the list. When we did it back when Deepwater Horizon hit, we were already in being approved. We did the additional safety testing, LD50 testing, water safety testing. Our product passed with flying colors that we can apply it to shorelines. The Coast Guard has approved it to be applied to water if we need to. It can be applied to land. It can be applied anywhere without any safety issues. That's what's important from the standpoint of our product. And there's, like I said, we export this around the world. I'm in 9 different countries with it. No country's limited our access. It's safe, it's natural, but we are moving bugs as well. This particular project, they get natural spills of gasolines and oils at their depots, their transfer stations within. So they started thinking to themselves, because they heard me talk one day, if you do it fast, it doesn't become a problem. So have a little work truck with a 50-gallon tank that you can go out and hit these parking lot beds or these fill valve areas and do it on a regular basis so it doesn't build up and you have to excavate or have a big problem. Crude oil, 30 days. All your basic BTECs knocked out except for the total xylene. And I think we went in there 45 days later in the xylene. Why? This was, it wasn't sweet crude, it was heavy crude. And that's probably why the xylene took a little bit longer. Sweet crude we consume real fast. Crappy crude takes a little bit longer. Gasoline spill happened basically on the same day. Again, same time frame, less than a month, it's completely gone. Again, it's consumed, it turns into H2O, CO2, and trace minerals. Hydrocarbons go away. Gasoline, diesel, fuel oils, crude oils, motor oils, unless it's synthetic. All of these things can be easily cleaned up. The faster you hit the stain, faster you hit the mark, faster you go ahead and manage it, the faster it goes away. Just like sodium and chlorides, the longer they sit in the soil, the harder it is to get rid of it. Crude oil's even more difficult because it will absorb itself into soil particles. So a lot of times when I'll get testing data as far as the levels of contaminant, I did a project for Devon Energy in Canada where they had a 15-year-old stockpile of material. The levels came out, and it was one of my first projects 7-8 years ago. I was feeling really good about our product. I was ready to go. Got the data. The levels weren't really that bad. I said, man, we can get rid of this. I'm going to get in with Devon. They're going to love me. We went and treated it, tested it. 18 days later, I tripled the number of hydrocarbons that were in the pile. They freaked. I freaked. I was like, holy crap. They were like, what'd you do? Just treat our pile with hydrocarbons? What are you doing to me? Because our product is black in nature. So I called my scientist and I'm like, dude, what the heck just happened to me? He goes, call him and ask him how old the material is. Why? He goes, ask him. Got them on the phone. It's 15-year-old material. He goes, normal testing methods on old aged materials do not soak the material long enough to extract the contaminant. So you got a false level. What was being read is what's available to the environment, but what's totally in there was absorbed in. So the first thing that you did was go in and rip all of those hydrocarbons that were absorbed in there. You desorbed them for consumption, which is a good thing, so that you don't get constant breakdown over a period of time and look like you have a lag on your remediation. So now the first question on the questionnaire that we generally give people is, how old is this? Because if it's anything over a couple of years old, there's a high probability that the data that you're doing is slightly skewed. And either don't take any testing data in the first 30 days, and if you do, there's a probability that the number may be higher than what it originally was, because there's more there. So we're looking at, you know, finding out these issues so that you guys don't have them. I've mentioned this a couple of times. It's all about expectations. My job is to develop a plan, work with our distributors and contractors and clients to develop programs that are going to work, but more importantly, build expectations according to how much money you're going to spend. If you don't want it to happen in 30 days, or you don't need it to happen in 30 days, you can use a little less product. It will still get the job done because bugs will keep eating. And there's other ways that we can buffer the environment if it's heavy to go ahead and make it work. But the loading wasn't excessively high on this. Take a site like this. It's one of my customers down in Argentina. It's an 11-acre land farm for Petrobras. Everybody told them all you needed to do was to take all of these spills and everything, dig them up, haul them to this field, and spread them out, and Mother Nature will take care of it all herself. It'll volatilize the natural bugs in there. All you gotta do is plow it every once in a while. You're fine. And just keep it, don't go higher than 3 feet. So that's what they did. 11 acres. From their exploration sites, from waste areas, all of that, they just covered it. Unfortunately, 14 years later, it had hardly moved. They didn't do anything to it because everybody said, nope, you don't have to put fertilizers on it. You don't have to do this. You don't have to do that. This area where you see, we just went out in the middle of the area and sprayed a section. And immediately, within 2 weeks, all of these weeds started growing and developing, and they're like, what the heck's going on? We haven't been able to get anything to grow on this site. Even though you can see they turn it on a regular basis. There isn't any residual plant life in there. But within a couple of weeks, we popped it up, we resampled it, moved it. Now, because this was 14 years old, the same situation occurred. Our original data was relatively low and we thought it was going to be pretty easy to do. So we went in there and we did some deep cultivation. We went and treated it, retested it. Sure enough, the numbers spiked up and everybody freaked out, but stuff started growing. So they felt good. They were like, oh, the numbers are really bad, but oh, okay. Well, at least our neighbors aren't going to start wondering what's going on. So it took us a year and 3 different applications. Because we went in, originally we just did some shallow tilling to make sure we had the application right. Then they went in with rippers. And finally they came in with I think a D11 with some big rippers and got it down all the way through the 3-4 feet and got this turned up and turned over. And we worked the soil a little bit. Now it's good agricultural land and everything worked fine. Biopiling, we work with a lot of different facilities. If you have a large site and your depth of your contamination is a little bit deeper, bioremediation can work in a lot of different depths. It normally will start slowing down at 3 to 4 feet because we do need air and we do need oxygen. So it depends on your soil structure and soil makeup. But generally when you have contamination of that depth, usually excavation is an option, or dig and haul is an option. So if excavation is an option, we recommend being able to excavate the material up and out, just like you would on a dig and haul, but keep the material on site. We go ahead and treat the area and we start layering it back down and in. So every layer that you're putting back in, 6 to 8 inch lifts, you're treating and saturating with both the moisture and the treatment product. You kind of homogenize the soil as you bring it out. You also find out if you have hot spots. Because I remember one of the first hydrocarbon projects we did together, we had all of our data and we were going to do an excavate, treat, and replace. And when we were excavating, we found a large area right in the center that had big tar globs in it. That this was supposed to have just been a produced water drilling mud dump site. Wasn't supposed to have any of this stuff in it. And if we wouldn't have excavated, we wouldn't have known it was there. We were able to manage it, homogenize it, get it remediated. But again, we don't have laser vision eyes to be able to really see down and through profiles. So data and information about the site is really important. This particular site on the biopile, they were just looking to be able to do it faster. So again, relative loading levels, pretty fast as far as on our BTEX ranges and on our larger fragments. One of the things that you'll normally see is that if we're going through what I like to call the ABCs of hydrocarbon analysis, a lot of times what's going to happen is our larger fraction ranges are going to drop first, and we may actually elevate our lower fraction ranges. And the reason being is, if in fact what I'm telling you is true, which it is, that we have materials in there that break down hydrocarbon chains into smaller pieces and bits, it goes to show if you have a larger, longer chain hydrocarbon and we're actually starting to fragment it and break it down, it's actually going to start showing as a smaller size hydrocarbon until it goes away. So we're going to fractionalize it, so it's not unusual for us to start with 47 here, and the next sampling, this may actually stay at this number or slightly elevate, and this one goes up because we're moving them down the line as we're starting to degrade and consume it. Again, expectation of working with the regulators, trying to figure out what testing methodologies they need you to use, and then we'll translate what your expectations of when we want to do our sampling times, because if we do it too soon, you may see things that are going to freak you out, and we don't want you to freak out. Or we're going to do other testing so that we understand what it is in conjunction with it, but we always have to follow what the CAP plan tells us, because we always do what the CAP plan tells us. So quickly, application techniques. I don't think there's a technique that I haven't had the pleasure of doing. This actually is George's Feet, the one project that we were talking about where we excavated. This whole wall was just covered with this black tar material that we weren't expecting. And we did 2 of these. This was the second one. So this was a dig it, lay it back in, treat it, and saturate it as we go layering up. I work with a couple of different companies, equipment companies, with very specific material processors. That if we excavate it, we run it through, it homogenizes the material and treats it and coats it. I have 2 of these running down in South Africa right now. We do a lot of business with Total, a lot of service station and industrial sites. Dig, treat, and replace, good old geoprobes, land farming, soil mixing. For gravity feed, if somebody didn't get my just before, this is a smaller gravity feed site where we brought the geoprobes in and they truck pushed 2-inch hole in and then inserted a 1-inch poly sleeve down into the holes. And then the top of it came out, and we just plumbed it in to our feed tanks with the diluted product. We cracked the valve and just let it saturate the area. In this one, the soils were really good. This was up in Maine. We did that for the Air Force Base. Those holes on the backside were offset, and then there was a third or fourth row behind it. And we just opened the valves, cracked them, just so that was trickling down. We left, we came back the next morning. The tanks were empty. We put a little bit of flush water down and through, came back, and that was just Jet A and some fuel oils. Now we're at an old tank farm that had a ruptured line. This is actually me in Australia. 145 degrees when I was standing on that black liner. That was a, had hydrocarbons in it that we were taking care of. So our experience is pretty vast as far as helping everybody go ahead and figure out different ways of doing things. I'm going to spend just a minute on this, not a lot of time, but everybody says, ooh, how much does this stuff cost? You can use this cost factoring for both sodium and chloride remediation as well as hydrocarbon. It may vary slightly depending on your cost structure, but dig and haul today is usually, depending on the area of the country, and that number has gotten bad, could be anywhere from 55 to 200 per cubic yard. I know a couple of areas are up as high as 300 a cube now because the disposal sites and where they can get rid of the material is a lot further away. The other thing that's more important today that you want to check with your legal departments, most disposal sites like Republic and Waste Management are now going ahead and having their companies sign on to their liability for the material that they had just accepted and charged you to accept. So dig and haul is no longer you pay and your problem is gone. You just paid a lot to make it go away, and oh, by the way, now you're stuck with everybody else's crap. And if there's a problem, you're on the name list and you now become a nice little thing for your attorneys to go ahead and take care of. That's very important that you guys now on the dig and haul alternatives are no longer, and if it is produced water and you're digging and hauling produced water spills, since it doesn't kill anybody, you're getting looped into all the other crap wherever that disposal site's taking. So your liability, just because it's just salt water, doesn't change. You're still on the liability hook. So really look into that, and that makes that cost a lot more important. So your cost can be anywhere from $15.50 to $35 a cubic yard. It can be more if you need it done faster, if the levels are higher. But that's a pretty good rule of thumb. And that does include some contractor costs as well as the cost of the product. In our experience, those numbers are up and down right now. Some areas, contractors are getting pretty aggressive with their pricing because they're just now getting their crews back to work, because there's work to be had. Whether we have to excavate, what kind of company we're dealing with, but that's not a bad rule of thumb. And again, age of spill, how quickly you want it done. My adage is, speed is expensive. I'm happy to do it, but if you need it done in a shorter period of time, it just gets a little bit more expensive because we have to put more product in there to work faster. It can be done. It's just more expensive. But that's the choice that you have. We'll power into kind of a new concept that we have. As you probably caught on, one of our philosophies that we're pitching and getting great acceptance from a lot of our refinery partners and a lot of our operator partners is that if you take care of something on a regular basis, it's much more cost effective. If you turn a blind eye to it, it just gets more expensive because it's either bigger, deeper, or absorbs into it. So whether it's a tank farm, a disposal site, an exploration site, or a refinery, you might want to get into some normal hygiene or response programs. If you're a produced water hauler, there's possibilities if you normally will have maybe a few gallons get out when your hoses run or you get a hung valve or something. Maybe you want to consider having some diluted product on your truck with a little sprayer that he can actually go ahead and dump it on the spill. Or if you have a service truck that goes around, he can have a little tank in the back of his truck with some diluted product and hit these areas quickly. Again, you hit it fast, you hit it quickly, it goes away fast, just as we've demonstrated. More importantly, if it's a vegetated area, it's not going to go to unvegetated. It may shock the plants, but you're going to stabilize that site quickly and be able to respond to it. Probably the most impact is refineries and tank farms and things like that are becoming, or wellheads are coming under greater scrutiny from a lot of inspectors because there's not as much exploration going on. So they're now looking at other areas with a little bit more of a fine eye that they didn't really have time to go look at before. Not that they weren't doing their job before, they were just busier and stretched a little bit more. Now they're not doing so many things, they have more of an opportunity. So this is a prime example of going into a wellhead. This was actually sprayed down with two different products. One was our pull it out because it was kind of heavy and gooey in through these areas while they were setting up the pressure washer, and then as they hit it with the pressure washer, they just had the injection of our ultimate. Basically went from there to there, safe on painted surface, goes ahead and exposes the colors of your valves, cleans off everything for good operation, whether it's working in your maintenance shop, and I'll show you that in a minute, cleaning your equipment or working on engines or parts, and you want a biodegradable or remedial characteristic product. The good thing about this is, most of the time, if you go ahead and clean this off and it goes into the soil, now all you did was move the problem off of all of that stuff down into the soil. But not with our new cleaning products. Our new cleaning products have the same bioremediation characteristic as our heavy lifting Soil RX. So not only are we cleaning with a biodegradable, safe product, it also has a remedial characteristic once it hits the soil. Now what we do recommend for our customers when they have sites this bad and we need to clean up more gravel or something that's been stained over a longer period of time, let us come in first and put the Soil RX, which is our heavy lifting remediation product, down first, and then go ahead and do the cleaning. Our refinery partners are jumping all over this because a lot of them now are looking at their turnaround costs. And one of the, if you're doing a major refinery turnaround, you could be spending $10 to $50 million. 15 to 25% of that is cleanup remediation for the crews to come in and do the turnarounds. Well, that's an awful lot of money that if they start cleaning themselves on a day-to-day basis, and more importantly, you can actually do better inspections, you can use the valves, your deferred maintenance and things of that nature are a little bit better, and it's very cost effective. It was an hour's time with George and he had a guy supervising him and $25 worth of product.
Hold that picture for a second. The interesting thing on this, the company had put some product on this wellhead and been sitting there for 3 weeks and made some claims. And nothing had happened. So I got permission to come in, and as some of you know, I'm a little anal, and I choke you up there. I took a scrub brush with that pull it out product and I thought, well, it works quite well by itself, but I could maybe help it a little bit by just taking a brush and start scrubbing this whole area. And after everything was done, not only the wellhead, but this area was coated as well with oil. You can't really see it in that picture. And in addition to that, the gravel surrounding this wellhead, collectively, I said, it took 65 minutes to do that. 3 weeks, this other product been sitting on it, hadn't done anything. Came in, hit boom, boom, an hour, and it was done.
So to get a little bit better idea, this actually from one of my forklifts, a side shift valve, and it just blew out on me a couple of weeks ago. So I went and pulled it off, and before I went and took it in to get rebuilt, I'm like, I got a great cleaning product. And I know a lot of guys, we've been trying to work with Safety Clean and some of the other parts washer companies, and they wanted a little bit more evidence as far as how it works. Well, out on exploration sites, you're doing a lot of cleaning of different equipment coming back out of the hole and things like that, and that usually creates a potential problem with residual hydrocarbons and all of that. So we work with a company, some of you may be familiar with them, called NOV. They restore drill bits and drilling rig parts, and we take care of their wastewater and some of that. And they're liking the new products because simply I dropped it on a couple blocks, sprayed some ultimate on it, flipped it over, sprayed ultimate on the other side. You could see how quickly it was breaking down all the greases and oils and buildup. Then I did run, had a glove on, just ran my hand over a couple of the heavy areas, and then I rinsed it off. Now the nice thing about this is normally when I had used cleaners and things like that before for my parts, if you notice at the base, and I meant to get a picture of that and throw it in, I threw it on the step on the outside of my warehouse, and it's all grass underneath it. Didn't affect the grass at all. Again, all biodegradable, all safe. I rinsed that material off, rinsed it down and in, and I knew it continued to break down the hydrocarbons as well as doing the cleaning. So it's a safe and effective alternative. And again, companies are looking for safer ways to do things, as well as trying to get a new process in place to where you can clean as you go. And that's effectively where this comes in.
What if you had kept your solution after that? Would it have been spent? Could it have been reused?
Nope. What it would be doing is in the tank, and that's why we're working with a couple of parts washers right now, is that the bugs are going to continue to consume. The other components that we have that help do the cleaning and are biodegradable do that job, but the bugs are going to keep consuming. So what we actually think is we're potentially going to get better life out of that parts washer solution, because as it's sitting there, it's going to constantly go ahead and be consuming. The only thing that we're not sure about is long intervals of it not being recirculated, because usually a parts washer is used and then it's shut off, and they'll come back and do some more parts washers. What we might have to do, because this is an active environment, we may have to have a modified tank, and one of our partners have already said I can do that. Just have like an aquarium bubbler. It only has to be that much just to have a little bit of movement in that drum tank underneath the actual unit, so it keeps chewing up the hydrocarbons. That's the only thing that bugs need, is air and food. If they don't have either one of those, primarily the air, they're going to go sideways in a hurry. So that's the one thing that we're doing from the parts washing side. But we have a lot of our equipment operators' exploration sites. Again, that goes back, if they're cleaning their equipment and they've designated an area, and I know it's a contained area, it's still something that they're going to have to clean up eventually when they leave. And going back to the part of directional drilling, they now are positioned in one location for an exceptionally longer period of time. So the impact to the environment around that exploration site is now twofold, threefold, fourfold. Because directional drilling, they don't have to keep moving their rigs. They're just going to keep pointing it in a different direction, and the impact in that general area could be significantly greater. So again, if you do it quicker and faster, the cost is going to be much more effective. Last part, I talked a little bit about wastewater. whether you're a recycler of materials, you do cleaning, some of you will have wastewater catchment areas. That one happens to be a pretty gnarly one, but we see a lot of this in our refineries. This happens to be a new customer of ours in China. Again, being able to remediate high volume wastewater, if anybody has issues with hydrogen sulfide, whether it's in their crude oil that they're transporting or their wastewater that they're transporting, or if they have any holding or catchment ponds that has H2S, we have H2S treatments. The unique thing about our H2S treatment is, again, we're doing it naturally with a similar biopolymer. And essentially what we're doing is we're stopping the ability for sulfur, to convert into sulfides. So once we bind, we're going to increase the sulfur level that may be in the oil or the water, but we eliminate the H2S. And we also alter that environment so that H2S can't develop. So a lot of our competitors that use an oxidizer or use a chemical additive, some people I know use a formaldehyde base to manage H2S at disposal sites or things of that nature. Those break down over time. Our product won't break down. We require two things for it to go ahead and release or reverse any of the remediation that we've done, whether it's to metals or sodium and chloride. Either it needs to go higher than 600 C, or you need a harsh acid event. Now, when I say a harsh acid event, I don't mean acid rain. I mean something that would peel the skin off of our bodies, melt the metal on our cars, and completely destroy our civilization the way that we know it. That kind of acid event. So the probability of those two things, unless you're forcibly going to try to cook or burn the material, isn't really going to happen. So our models and our experience, we know once we bind it and we take care of the problem, either we make it go away or it's bound and held for basically forever. So again, wastewater, we have a variety of different issues. There was a great question that was earlier as far as, can we treat produced water and make it better? And I know I briefly answered it, and I'll expand it just a little bit. No. If it's in a tank, if it's in a tanker, I need other organics for my chemistry to go ahead and work and react properly. Will I go ahead and precipitate some of the sodium and chloride out of it and drop it down? Yes. Would that water be...
When you say drop it down, will it fall out?
It will precipitate down to the bottom.
Okay.
A small portion of it.
Okay.
Would that water, if you treated it and you spilled it, would it have the same effect if it wasn't treated? No. If you pre-treated it and dumped it on, it's not going to act like produced water. It's going to act like treated water. But for whatever reason, just trying to work produced water in a tank, haven't got the magic completely dialed in. Or I can't do it cost effectively because I have to add some other componentry to build organics to get all my chemical reactions that I need in the water to happen. So when I put those two products together, nobody will pay for it. So the answer is no, I can't do it. Now, the difference being is if it goes into a pond or a lake that naturally has sediment, naturally has organics, naturally has some characteristics of soil, we can help neutralize the impact of a produced water spill that goes into a body of water. The product's safe to do that. Your fish kill that may occur is going to happen whether we treat the water or not. Unless we had pre-treated the water and knew that you were going to spill it in there, the fish kill is going to happen because the sodium and chloride is more going to take the oxygen out of the water, and that's what's killing your fish. It's really, there's certain species of fish that are intolerant to sodium and chloride, but you would have to almost put them into a pond of it to kill them. So usually it's more the oxygen side that's killing the fish when you have a spill that goes into a body of water. So once that gets in there, is there something that we can do then? Yes. Usually we're going to go ahead and recommend that there's a treatment done to that water, and then you pump it out and you bring in new. But just don't pump it out and bring in new before you pre-treat that pond so that it treats the sides and the soils and the sludge that's already in there. Because the new water that you're going to bring in is just going to become saline water again for what's left on the sides. So water is a little bit more of a challenge from that standpoint. Treating organics, or whether that had hydrocarbons go into the water, that's easily taken care of. We do that. Sodium chloride is a little bit more difficult, but we can clean up hydrocarbons in wastewater. So if you had produced water that you needed to get rid of the hydrocarbons out of before you disposed of it, that's easy. We can do that in a tank. We don't need anything special. It's just the sodium and chlorides or metals are a little bit different chemistry that we have to have different things, and one of the things is organics that helps us along. So we can clean up municipal sites, industrial sites, sludge, odors, all of that kind of good stuff. And the last part, I appreciate your patience. We're also an interesting company to where we have a very diverse line of products. One thing that I failed to mention at the beginning, we started in 2003. We have a complete division that sells products to the turf and agriculture industry. We have natural fertilizers, soil amendments, soil conditioners. So one of the other values that we bring to the table is when we go into a site and we're also asked to revegetate it or give recommendations to get it viable, you're talking to a company that can also, along with all of our remedial products, can bring in natural soil conditioners, fertilizers to help it grow and get it turned around and moving faster as well. So under one roof, we can handle anything from wastewater to salt correction to soil RX. And again, that's our heavy lifter that's NCP listed. PWT 1000 will take care of hydrogen sulfide and the other fats, oils, and greases in wastewater. Oil 1000 is an actual certified approved product to go directly into crude oil that has that hydrogen sulfide and will not change or alter the quality of it at all. And once we go ahead and we bind and we eliminate the H2S, it's safe to run through pipelines, it's safe to go in transportation, and we guarantee that the H2S will not come back. Once we eliminate it, now there will be a higher sulfur content. It's their problem to go ahead and remediate out or process out. But we go ahead and convert the hydrogen sulfide back to sulfur. Composting products are cleaning products. So essentially, our goal is to offer different opportunities and different products and ideas. I hope the information that we provided to you was valuable. Hope the lunch was good. And from me and from George, I certainly appreciate your time. If there's any questions or anything else that we can help you out with, and as always, feel free to, you have my card, you have George's card. If you have certain projects that you want to discuss, feel free to give us a holler. George will be happy to come out and take a look at it if he hasn't already looked at some of y'all's stuff. And George and I talk way too often. I mean, we talk quite a bit.
Yeah, too often.
Yeah. Thank you very much.
Thank you.
If you've got a spill, it's going to have oil with it, and it's going to have your salt water with it.
Combine the product.
You do combine the product.
And we'll drop, depending on which one's the dominant one, we'll change the proportion of the application rate of, say, the soil. Let's say that the salts are higher, so we know we need a certain amount of SA 1000 to take care of the sodium and chloride.
Okay.
and we have a lower level of hydrocarbons,
Right.
then we can combine the two on the same application. It'll take care of it at the same time. The biopolymer is in all of the products. Now, the SA1000, which is for the sodium and chlorides, uses a combination of a couple different polymers. One of them is the standard polymer that is positive and negatively charged, but it's also got another one that's non-ionic, and that's to work more on the chlorides. They have a non-charge that works better, because chlorides are just a pain in the ass in getting the proper reaction. So we came with this blend that works better. So the SA1000 has some, the Soil RX has some of the polymer that's used in the SA. So if I have a dual spill, I know that if I need X amount of this, I can reduce that one down, and I just reproportionalize. And the products are compatible to be put in the same tank. Our dilution rates are very similar because we're looking to kind of saturate and to drench it. So that doesn't have a problem. But we can mix all of our products together. So if it's a dual problem, we can do it one time, one technique.